Our solar system is one of, if not the only system yet observed to have shown signs of life. Although life originates from a celestial body, it can be maintained on an artificial satellite. These satellites are referred to as space settlements. In this video, we will be discussing how to find an ideal location for a settlement and discuss the feasibility of the planets in our solar system. Orbital settlements can revolve either around a star or a planet. Now, the location of a settlement is chosen based on certain factors, so the settlement can sustain life. These factors are as follows. Number 1. The distance from the star. Since stars emit thermonuclear energy, orbiting too close can be harmful due to the high radiation intensity. On the contrary, being too far would hinder power generation because the settlement doesn't receive enough solar energy. Number 2. Nearby celestial bodies. The settlement must also remain close to natural celestial bodies as their gravity protects them from space debris, while their electromagnetic field reduces cosmic radiation incident on the settlement. You don't want to be hit by a giant asteroid or zapped by a space radiation now, do you? Mercury has no natural satellites, which means that the only thing to be considered when designing an orbital settlement at Mercury is its meager gravity of 3.7 meter per second square. Being the closest planet to the Sun, the surface facing the Sun has a temperature of 427 degrees Celsius, while the surface that faces away is frozen at negative 173 degrees Celsius. For a settlement, this climate can be problematic. In order to maintain a healthy plant development, the tori must be shielded from the excessive radiation and hostile climate of Mercury. A smart way of resisting this radiation is to build a huge shield of solar panels to prevent overheating while simultaneously generating electricity. Venus has no natural satellites and is referred to as the second largest terrestrial. This makes Venus an ideal location for orbital settlements. However, surface of Venus is too hostile for development as the temperature reaches up to 462 degrees Celsius and atmospheric pressure is almost 92 atm. Venus is the only planet to rotate in the opposite direction of other planets. This implies that the settlement on Venus will receive optimum light. The downside is that the development and growth opportunities are restricted. The optimum location for an orbital settlement is Earth because of its numerous advantages. It receives steady radiation intensity from the Sun, it has the highest potential in tourist industry, and the development on the Moon, also known as Luna, is well expected in the near future. The cost of building a space settlement is also lowest on Earth as the material and components can reach the construction site using minimum fuel. The water, food, and clothes reserves on Earth can also act as stock for the settlement. Unfortunately, due to Luna and other artificial satellites, calculating the ideal height for the settlement from the surface is intricate. Mars is the preferred host for an orbital settlement because it has fertile soils as well as traces of water reserves. The gravity of 0.37 g and the atmosphere are conducive to planetary settlements, while the short distance to asteroid belt can lead to mining possibilities. As a result, business and development sectors will easily progress on Mars. It is the only planet after Earth that can support both orbital and planetary settlements. The reason is that it is terrestrial and has only 2 natural satellites. Also, Elon Musk is obsessed with colonizing it. The asteroid belt can be helpful in providing resources for orbital settlements. However, this belt and all other planets that lie outside of it are unable to host orbital settlements. The planets Jupiter, Saturn, and Uranus are all gas giants, and although they have frozen water reserves, the temperature and sunlight intensity is too low for feasible development and power generation. Another problem faced is the large number of satellites. For example, Jupiter has 79 moons. They would cause hindrance for communication, interplanetary transit, and power generation. Hence, Jupiter cannot sustain orbital settlements. Similar problems are faced on Neptune, an ice giant with surface temperature of negative 201 degrees Celsius. Pluto cannot host planetary settlements because sadly, it is not a planet. So there you have it, fellows. We hope you got an idea about the basic criteria that are used to determine ideal locations for a space settlement and which planets are best suited for being our next home. We hope you enjoyed this video because we certainly enjoyed making it for you. Peace out.